Hi, my name is Elena Castellanos, and today I will be showing you how to calculate enthalpy and how to determine if a phase change is occurring. Problem. Imagine that you have a chamber in which a chemical reaction is taking place. The chamber is surrounded by 1,000 milliliters of liquid water at room temperature. If approximately 250 moles of a product is produced with the reaction, what change will be experienced by the water surrounding the reaction chamber? I was assigned the equation that stated pyrite and oxygen combine together to create iron oxide and sulfur dioxide. I found information on all three elements in my equation, like the atomic number, common isotope, group number, period number, family name, electron configuration of a neutral atom, number of valence electrons in a neutral atom, and number of energy levels in a neutral atom. In order to balance this equation, I had to add coefficients. A coefficient is used to add the minimum amount of moles needed to balance an equation. I then went on to add 4 moles in front of pyrite, 11 moles in front of oxygen to the reactants, and 2 moles in front of iron oxide, and 8 moles in front of sulfur dioxide in the products. Then I distributed the moles to the subscripts, thus balancing the equation. To find enthalpy, I had to find the heat of formation for all the compounds in my equation. I then multiplied that value by my coefficients to get enthalpy. I then did this for all of my compounds. Then I combined the enthalpies of both the reactants and products. I calculated enthalpy by subtracting the reactants by the products, giving me a positive 3,310 kilojoules over moles, which is an example of an endothermic reaction because the reaction chamber is releasing energy, so that the water temperature increases because the water absorbs energy. I then multiplied this value by 250 moles to find the energy released, which is 827,500 kilojoules. Since we have an endothermic reaction, we must change the sign to a negative in order to solve for the change in temperature. We must also change 4.18 joules over grams into 0.00418 kilojoules over grams degrees Celsius. Then isolate change over T, which gives you negative 19,766.5 degrees, negative 19,766.50 degrees Celsius. Found the final water temperature by subtracting negative 19,766.50 degrees Celsius by 21 degrees, giving me negative 19,787.50 degrees Celsius. We then can infer that the phase change occurring is freezing. Thanks for watching!